So here we have a comparison. We want to compare which is more mass, 173 atoms of gold or 7.5 times 10 to the negative 22nd moles of gold. Oh, silver. Thank you. Okay, so if we want to compare their masses, it makes sense that we probably want to convert them both to grams. That will be a good comparison. If I know how many grams or how much mass the 173 atoms of gold have, and then I can also convert the moles of silver into grams, whichever has more grams will have more mass, because grams is the unit we use to measure mass. If I wanted, I could also convert them both to AMUs, because that's also a unit of mass. Whichever has more AMUs would be the one with more mass. That would be okay as well. So whatever's easier for you. It's going to be the same number of conversions either way, so it doesn't really matter. So maybe I'll just work with grams. So I want to know, first off, how many grams of gold are there in 173 atoms of gold? And then secondly, I want to ask how many grams of silver are there in 7.5 times 10 to the negative 22nd moles of silver. So the silver one is easier. It's just one step, because if I have moles, moles is a great unit because it's the bridge between tiny amounts of things like atoms and molecules and laboratory scale amounts of things like grams. So I know if I have moles, I can always convert to individual numbers of particles because I can use Avogadro's number. Or I can convert moles into grams if I know what the identity of the substance is, because I can use the mass on the periodic table. So that's what I want to do in this case. If I've got moles of a substance and I want grams of that substance, I just need to know what the substance is, because the relationship between moles and grams for a substance will come from the periodic table. So for silver, the molar mass is 107.8682. And the molar mass is always the number of grams of a substance equal to 1 mole of that substance. So that will give me grams. 7.5 E negative 22 times 107.8682, and I get 8.1 times 10 to the negative 20th grams. For the gold, I'm going to need a couple more relationships, so maybe I want to make sure I set those up to make sure I'm on track. So if I want to convert to a laboratory scale amount and I've got tiny particles, I know I need Avogadro's number. So for the gold, I know 6.022 times 10 to the 23rd atoms of gold will be equal to 1 mole of gold. So I can use that to convert my atoms to moles, and then I'll do the same thing with the gold that I did with the silver to get from moles to grams. So for gold, it's 196.9666 grams of gold per 1 mole of gold. So those are the two relationships I want, so I'll use them here. So first I want to cancel the atoms. Then I want to cancel the moles. Oops. Molar mass is always the number of grams equal to 1 mole. So the atoms cancel, the moles cancel. I've got grams. So I can make my comparison. So I'll do 173 divided by 6.022 E23 times 196.9666, and I get 5 point. Here I've got 3 sig figs, so I go 66 times 10 to the minus 20th grams of gold. So since the number is larger for the silver, that means that quantity of silver is more mass than that quantity of gold.